welcome our next speaker, Sebastian Buczyński, talking about having fun with Pydantic and pattern matching.
All right, let's start then. It's so big pleasure to be at PyCon US. I flew all the way back from Poland, Central Europe. I work as a software architect at a company called Sauce Labs. I also do some part-time consulting training at Bottega IT Minds. I like memes, so you can expect quite a few during this presentation. I write blog under breadcrumbscollector.tech. And like my mission that I've been doing for quite some time was educating Pythonistas about software engineering, because many challenges that we face are not specific to Python. They've been already solved maybe in other programming languages, in other communities. So let's just take it from them and make it our own. But today the topic will be quite different, because we'll be talking about this beauty. Who uses it? This new match case. This is very few, given that this has been with us for 4 years now. And some folks seeing this are like, oh, Python is finally getting switch. Except it's not, and I'm honestly tired of explaining that it's way, way more than just this dumb switch. And my goal of this presentation is also show you what's the difference. So, but for those who don't use it, and maybe it's the first time that you saw it, let's use a couple of minutes to explain, to introduce it. So let's say you have a value called price, and you have assigned integer of 200 to it. You can use this keyword match and put this name over there. And then you can throw plethora of different case statements over it. So in the first case, we have 100. So if it matches, or in this example equals 100, you will see cheap on the screen. If there's 200, you will see expensive. And there is also a catch-all. In case nothing else matches, nothing else is equal, then we'll see this no idea. Okay, so let's see how that goes. What we'll see on the screen in this case? Yeah, I can see some voices, expensive, that's right. And this case? Seriously? Nobody knows? Just pulling your leg. Of course, it's no idea. The last one, catch-all. Okay, and in this case, data is a tuple, 3 element, and we have cases like dictionary, a tuple, or, well, again, no idea. How do you think? Which will fit? This is a tricky one. Actually, it's a tuple, because if you put just brackets, it will think that you are trying to match an empty tuple. So you need to use this tuple. At least that's what I found out. Okay, and whenever data is a dictionary, what we'll see? Yeah, it's a dict, exactly. Okay, and in this case? Yeah, it took a little more time, but of course that's a dict with a name. So like our first case assumes, okay, this is a dictionary, and it will have a key with a name and some undefined value. We don't care about matching it, so it's also fine. Okay, and let's introduce a slight twist. What we will see there? Right. So you haven't fallen for it. But if you ever think about using match case, if there is one thing that you should remember, is that ordering of these cases is significant. This is one of the key takeaways of this talk. And let's use a funny video to show what happens when you neglect the order. Yeah, so apparently the square pattern was the first one on the list. So if you not intend to have such an outcome, please be wary of the ordering. This is pretty similar to how exception handling works in Python, right? You can also stack a bunch of different except blocks, specifying which type of exception you want to handle. And if you put an exception above value error, well, you know that exception is generally more broad. A value error inherits from it, then you render the last block at that code, because it will never be reached. Whenever whatever is inside try except will raise a value error, it will always fall into exception. So it's pretty much the same rule. We check from the top to the bottom. Okay, this was a pretty nice gimmick, you might think, but does it have any? Is it useful for production? Because I think there is a reason that also people are not using it. There were very few hands raised when I asked. So I want to present you a specific case when we used it. It proved useful, and was also implementation was pretty concise, and we'll see a bunch of Python tricks to make the implementation even more concise in the end. So let's see. So this is a use case or a case study when we have consumption of a stream of events. What does that mean? That there is some source, like maybe Kafka, maybe RabbitMQ, maybe Redis, whatever, any other solution, and you will be taking data piece by piece from this source. What's important is that the stream is never ending, meaning you cannot count how many elements are there. There will always be new elements coming in after some time. And each of them may require some special handling. Our job is to write that consumer on your right. Right, so how does an individual message look like? So let's assume for purpose of this presentation that this will be just a dictionary. Normally when we send things over the wire, they're in a binary format, but let's say they're encoded in JSON, so we can actually read it as human beings. So this is an example message. It has a type key, which holds account created. There is an ID and some name, pretty much. There are quite a few types of messages that we'll see in this stream. So we can have apart from account created, also account updated and account deleted. You can see that the set of fields in each message is a bit different. Of course, the messages are mixed in terms of types. So you can see some 2 accounts are created, then 1 account deleted, and so on. Some will be regarding one user, some regarding other users, and so on. So there's no assumption you can make about the ordering in the messages. And also to make it a bit more interesting and also more close to reality, some of the messages will be malformed. I will not be that mean to put some binary nonsense, but let's say that some of these messages will have unexpected format, like missing type field or whatever. So from the very beginning, we know that some of these messages we will not be able to handle, and this is very important. This is also a pretty realistic scenario that whenever someone works in an event-driven system, then when messages are being changed, we kind of lose the ability to parse them sometimes. But this is perhaps a topic beyond scope of this presentation. Okay, so our job, we have this let's say bootstrapping code already set in place, and we have all this. All we have to code is this function handle, which accepts a payload, which is a type of a dictionary, a single message, and we are to fill it with code after we are familiar with the input data. So we can pretend it's 2020 again and just throw a bunch of if statements on it. This is pretty simple implementation. For all the messages we know, we just check for the type field. If it is what we expect, then we should put there the rest of handling logic. And if it's something that we don't recognize, then we have also this logic of, okay, recovery, time to log it, or whatever. I am not able to handle it. However, this situation, this approach actually escalates pretty quickly. The types of messages, especially in an event-driven architecture, can change over time. So we will find ourselves going back to this function, modifying it over and over again. And sometimes, like with account updated, we may find ourselves in a situation when we want to actually distinguish two specific sub-situations, so to speak. So whenever someone updated to paid or set to trial. And yeah, you can see that we're getting more nestings there. Inside those nestings can be also some validation, some error handling, and so on. So this is not going to age well, this piece of code with this approach. By the way, is there anything else that you don't like in this solution? Mm-hmm. Okay, so just so I repeat, because I'm sure it wasn't caught in recording. Someone mentioned expectation that the type field is present. Yeah, that's one of the things. So it's implicit like expectation. There is some schema followed by these messages. Okay, anyone else? Sorry, come again, please. New status. Oh, what's wrong about it? Okay. Okay, so I'll repeat the whole thing. So the other notice was, okay, what about the field new status? For now, we can see it has one of two values. What if it has another value, like paid trial, I don't know, past due or whatever? So how do we handle it? We also, if this happens, we'll also have to go into this function and probably modify the code. Also, you notice that with the current implementation, if we get under this branch of account updated and we don't fall under if or elif, we essentially exit this function without any error. So this can get tricky. Right. Thank you for all the suggestions. So let's see how we can refactor it using this match case statement. So we'll start from just putting a match payload and this catch-all statement. Like I will do it really slow, step by step, so like we don't get lost. And at the moment, I made the situation worse because I only added 2 levels of indentation and no actual change in logic. But slowly, bear with me. Okay, so the first thing we may do, we can change this check for type account created to a pattern that, okay, I expect this will be a dictionary. It will have a key type, and the value will be account created. I'm using literal values, so there is no ambiguity. I can do the same trick with account deleted. There's nothing magic here. It's all the same. And account updated, I will have to deal with it in 2 steps. So first is, okay, I can pull just the fact of type and equals account updated. And then I have these 2 distinguished, let's say sub-situations. And I can also represent them as separate patterns. So the first one will be, okay, this is something that has account updated and new status equals to paid. And the second case, account updated and new status equals to trial. So whenever we are thinking about the latter problem that you identified, that someone identified from the audience, what is this new status has a new one of new values. So now there are 2 possible, but what if someone adds, I know, unpaid or past due or whatever, that will then also fall in this catch all, oh my God, what is this? So we'll at least notice it without like failing silently. Right, so we eliminated this extra code nesting, and we've been like by now very specific and prudent about whatever is in this data up to the point, because I will show you a few more steps that we can do here. But there is one thing that I dislike very strongly about this code. Can you smell it? Like a dead snake. It's passing dictionaries around. So of course, this is the entry point to the system. This is where we receive this data from the scary outer world. This is fine, but the code like below, once we, for example, recognize what kind of message is this in a case, we kind of, okay, we recognize it, and then we have to still rely on this untyped dict. Okay, what's there? What are the types of the fields? What's this? So back in the day, like I remember this very well, we used to pass around a lot of dictionaries around, and it was always difficult to figure out what's inside them. So once we have typing and once we have Pydantic, which is also another type of another part of this talk, we shall fix it. Right. By the way, I wonder if this is an official Python 2 logo by now, but yeah, let's move to Pydantic. Cool. So in a way, we know what's the schema of the messages. We know what kind of fields are there, what to expect. We also know what are their types. And pretty much we can create a Pydantic base model. By the way, this is kind of the tasks that also, let's say, ChatGPT or other AI assistants excel with. So, hey, this is piece of data. Can you write me a code for it? And if you think about it, Pydantic model is also kind of a pattern, because it also describes named fields, what are their types, and what we get for using it is some extra data conversion, some validation, and so on. So this also kinda can deal with a situation when we are starting to get an unexpected value in one field. Okay, but the bottom line is that after feeding this in the last two lines, after we feed the Pydantic model with dictionary, unpacking it, then we get well, something that we know is valid. It has types as expected and so on. Otherwise, we'll just get a validation exception. So I will just use one more trick because it will be helpful in the following steps. We can annotate the type not just as a string, but as a literal. That, for example, for the account created, a specific description of one particular message, we expect this to be always account created string. No other format is interesting. So whenever we also pass, like type is Bazinga in this case, but we would get an exception. And you can figure out what the next steps are. I could write these classes for all the other message types. I will spare you going this step by step. I will also use the same trick with literal in case of account updated. You know that old status in new status can be one of two values. Of course, if I would pass something else, I would also get an exception. All right. So now we can come back to our code with match case, and once we recognize the message type, we can create an instance of a matching model. And tada! From now on, no code that will be handling this event instance would have to deal with dictionaries anymore. But you know what? Since Pydantic also kind of describes the pattern, it seems like we may be doing the same thing twice. The first we use match cases to recognize what kind of message it is, and then we feed it to, well, what we know already, and Pydantic model class. And by the way, this also means that whenever like we need to handle something else or change the patterns, then we always need to modify this function, which also sounds kind of suboptimal. But the cool thing about Pydantic is that we can actually replace the whole match cases just with Pydantic alone. One of the things that Python with typing introduced was unions, which means how to describe that the value can be one of possible types. And we create this on the slide, like using supported model equals to union of, it can be either account created, account deleted, or account updated. And then the rest of the logic for now remains unchanged. And then since Pydantic 2, we can use some magic called TypeAdapter. And what we need to pass to the initializer of the class is this. We can pass, of course, a single model. This also handles non-Pydantic data types. But we can also feed it with a union. So meaning, OK, this is a type adapter that will be doing conversion from dictionaries to one of these models. And eventually, adapter, we can call a method called validatePython, pass the dictionary inside, and we know that the event will be an instance of one of these three models in this case. If it doesn't fit it, it will raise a validation error or exception. I don't remember exactly. The bottom line is that you can actually do this pattern matching using Pydantic and only once. And if you still need to like have to control the flow depending on the type, you can now use pattern matching on types. And in case of new status and field, dictionaries, we were doing matching on key and specific values. On objects, we can also do it using attribute names. And by the way, this is pretty tricky because when you see this line like account created and brackets, your brain, which is not used to this syntax, refuses to parse this because we would expect that this is the line when the account created instance is created. This is not. In context of much cases, this means, oh, this is some instance of account created. Okay, this is the one is tricky. And in case of account updated, the middle one, this reads as, okay, this is an instance of account updated. It has an attribute called new status, and it's equal to paid. So yeah, this is one thing you have to learn to be able to read those match case statements. Okay, pretty much we saved the day throwing just more pip installable libraries on the problem. But then there is one issue with this code. It will occasionally explode in production. Can you see why? Validation error, right? But why? Under what circumstances? Okay, yeah, that's right. So when the message is malformed, like we get this unexpected format or whatever, then we'll get on the line with adapter validate Python an exception, and we will not be able to deal with it. Right, so we can fix it very easily by extending the union, adding any at the top of it. And of course, we need this catch-all statement at the end of match case, because otherwise we are not able to deal with it. Right, so now we solve the problem kind of throwing more types at everything. However, we can still do a couple more steps. So first of all, now we are matching on attributes. It may not be really bad, but we can also just introduce more specialized types for it. So account updated when old status and new status can be one of the values. We are actually only interested in two specific situations. The first situation we are interested in is where someone actually updated from trial to paid. So this is one specific transition. And the second one is that someone was paying but now comes back to a trial. So we can introduce specialized types. And let's say all other cases are not interesting to us. Okay? And in the end, we are able to just replace matching on attributes with more and more specialized types. However, now that we reduced all interesting situations to separate types, it gives us another very interesting possibility. We use functools single dispatch that's been with us since Python 3.4. And this allows to, calling different implementations based on the type of an argument. So first, we define this handling of any, like this catch-all, decorated with functools single dispatch. And then we can start adding more handlers to different types of events or different types. Since Python 3.7, the type is read from the type annotation of a function, so it's pretty easy to use. And then we just call this event handler function, and thanks to this register calls, the appropriate handler will be just called for us. So this, in the end, reduces the function to what we have here. This list of supported models or the union could be also pulled outside of this function. So whenever we have to handle a new type of an event, we don't have to modify it at all. For now, we would have to come back and just extend or shrink this list, but this union. But that's we could also do that. And in the end, this handle, apart from that, this handle function is stable, so it won't be changing anymore. And this is really a realization of open-close principle when this code is very easy to extend because we just need to register more and more event handlers, and there we go. So it's high time to wrap up this entire talk. So we started off from single match case statement, which is much more powerful than a switch case, because switch case only deals with comparing, checking for equality of special values. Match case can also, for example, match on types, like in this case, and this is tricky to read. It doesn't read an instance of, it doesn't mean that we construct an instance of coffee. It only means that this is an instance of coffee that we try to match against. And also, other possibility we have is to match on attributes values. Switch cannot do that. So this is where match case is much more powerful. But having Pydantic, we can also kinda replicate the pattern using Pydantic by using unions and TypeAdapter since Pydantic 2. In case of Pydantic 1, the syntax is a bit different. So if you're stuck with it, well, it's your exercise to find out. Okay, what's wrong in this snippet? Yeah, exactly. Thank you. So Mark told us that we're missing any, and this is very important. So it means that I actually taught you something. Okay, of course we could also deal with it by explicit exception handling, like catching this validation exception. It's also kinda fine. Also, note about Pydantic, this code misses a few optimizations that I wasn't keen on squeezing into the slides because I wanted to fit into the time slot. Read about Pydantic union discriminants if you are to use it in production, because there is a slight optimization that will make this just run faster, because in this implementation it will just try this one by one. And if we specify this union type discriminant, that it will just look in this type field, and this should work faster in general. And the other thing is that unions in Pydantic, this behavior can be customized. So if you're not just, if it doesn't suit you to just naively try from left to the right, you can also kind of overload this behavior. And finally, what we saw was introducing single dispatch. So we kind of remove the need to modify the handle function, because we can introduce just individual handlers based on the type of the event. Okay, what can I say? Start writing classes, because types are awesome. This was talk about pattern matching with and Pydantic and single dispatch. I'm Sebastian Buczyński. You can find the slides on under this QR code. Thank you. Okay, I believe we have 2 minutes, 20 seconds on questions. If you like, approach the mic. If not, I'll be around here, so. Okay.
Hi, I guess I have a question. Very nice talk. When you use the match syntax with with this thing that looks like an instance, right? Does it actually evaluate if I have some side effect in my init class, will it actually run?
Yeah, if you put something in the init, right?
Yeah.
No, it won't.
It won't?
It won't.
So it's just syntax?
Yeah.
It just doesn't do anything?
Yes,
okay.
This is tricky one, yeah.
Okay.
Yeah.
Interesting. Thanks.
So the end result where we ended up here was actually not using match case at all. We ended up with functools single dispatch. So as far as the use cases for match, are there some, do you think most of them actually, are you saying we should really end up using functools single dispatch, or what are cases where you still would advocate for using match that maybe functools single dispatch doesn't handle?
There are other cases, for example, in event sourcing implementation, when you also has a bunch of different types of events to handle separately, but you know the list in advance. Whenever you modify the list, you also need to modify the handling. So these are two things that you change together. So it's completely fine in this situation. Yeah.
All right. Thank you.
I have a question. I've been using Pydantic a lot for our one of the project, And one of the things that I've struggled with is like we have some data models that are nested. So like we have like, for example, this account created, account updated, and that is used within another model. And then that's being parsed in the Pydantic with the JSON. So is this pattern scalable for like a nested JSON model? So that's not like a good programming practice in terms of Pydantic models.
I would say it is. It's a standard pattern. Like I've been using it for years. Maybe it's an overstatement, but for quite some time that I'm comfortable that this is completely fine. One thing I would be on the lookout whenever you reuse the model for nesting. Is this actually the same model?
No, so for example, like when you say like the account created, account updated, those are the models, like for example,
Yeah.
and then that itself is used as another field within the Pydantic
Yeah.
model. So we come across some problems where when I was started using that, I didn't know much about the discriminated unions or Pydantic, but then we would get it passed as a wrong type, and like we will come across like bunch of issues with that. So I really like this pattern, but I was just wondering if we can use that for some sort of like when the data models are nested, or would that result in a lot of like use cases or like a little bit of explosive pattern?
Yeah, so in general, all of the cases that I've been using, it was working fine. But you know what? If you could come to me right after we finished with the Q&A, we can elaborate on the case. So
Sure.
yeah, it makes some sense. Cool.
Yeah, I was wondering, did you do any performance testing? So did you check that if you use like match case versus a bunch of if statements, did you check what the compute time ends up being between those two paradigms?
No, I didn't, but I can tell you off the top of my head that I'm sure that Pydantic will be the slowest, just because it does extra things. But I haven't been checking it, just because this is kind of an obscure example for production. Of course, there are other things happening that are much slower, so I wasn't really checking this particular part, which will be the fastest. It wasn't an important enough to do. Okay, thank you very much.